Drifting is all about control, speed, and style. It's thrilling because you're balancing on the edge of grip, sliding sideways, and nailing the perfect turn. It's like solving a fast paced puzzle, challenging, exciting, and super satisfying when you pull it off. Most racing games are in 3D, but 2D games are simple, fast, and just plain fun. And let's be honest, there aren't many 2D drifting games out there, so I thought, why not build one from scratch? The result? A tiny 2D drifting game. It's easy to play but hard to master. To start, clone this repo and let's get into coding. Alright, so after cloning the repo, you just go to the starter folder and you npm install, and then you just start the server as usual. And as you can see, we have this minimalistic basic setup, and we have this level component and the car component, which is represented as a sprite. And as you can see, just a sprite. I got this car sprite from the itch.io, will be in the description as well. I cropped it a bit. And now let's take a look at the package.json. So here we have this P2 library. This is a physics engine that we're going to be using. And now let's start from importing the P2 library. Import P2 from P2. And the first thing we need to do is to create some kind of world where we're gonna place our car. So for now, let's just create a world here as a ref. And into this ref, we put the new P2 world with the basic settings as gravity 0 and 0. This comes from the documentation, so it's not gonna change. And now we're creating the car body. We also use a ref for that. We have use ref. Let's give it a type as well so that it's easier to work with. We also have this use controls hook. The use controls hook is a standard hook to get the keystrokes, works with a single or several inputs. If you watch my previous videos, you'll see I use it quite often. So let's just use that. And now it's time to specify the parameters. We will want to specify them in one place so that it's easier to work with. The physics parameters such as width, height, mass. And now we have to add some abstract values for the engine and the brakes. Those will represent the force which is applied when we are dealing with the physics engine. And here we have the step. It's also coming from the documentation of P2. This is just to represent the frequency for the physics engine. This basically says how frequent is the calculation or recalculation of the physics of the whole world. Okay, here we just instantiate the basic setup for the physics as the component renders. So we have the car, we have mass, we have position. For now, let's just put the some thousands, whatever. We'll change that later. And to be honest, this part doesn't really matter, because we will anyway change the position, because basically the physics engine will change the position anyways. So let's leave it as is for now. And let's actually add shape to the car. And for that, we will also use the box thingy, which is coming from the P2. And here we specify our parameters. There we go. Now it's time to add this car to the world. And yeah, we just do it like this. The current add body. Okay. Also, we have to use the ref that we created at the beginning. Why it's important is because the component renders, and after this we have this ref, so that we can do whatever. We apply forces and so on. And let's not forget about the cleaning. So when the component unmounts, we just get rid of that. Yeah, we just delete it from the world. Also, yeah, the dependency array, and there we go. Now it's time to create our game loop. And for that, we will use tick. As you might already know, this comes from the React Pixi. We also have delta. Delta will be needed as well to adjust the physics engine. Now the early return. And here we just say car means car body.current, so that it's easier to work with. And let's get our controls. We already used it previously. And here we just get the pressed keys. Yeah, from here, from the get controls direction. And now we can just use it to specify the basic movement. Let's say back and forth. And of course, for this, we just check which keys are pressed. So we do this with includes. If it's up, what we're doing is we're just applying the engine's power, let's say. And otherwise, if it's down, we're just braking. Right? And when nothing's pressed, it's just 0. I think that makes sense. And then look, we have to use this engine power. So let's just use it. No, instead of this, let's just check if the engine is running, basically, like this. And here we will specify the forward vector. Okay, let's just specify this for X and Y. And now when we have this vector, we will use it. We will apply force. And there we go. We just apply the engine force now to the direction of the car. And yeah, the same goes for the Y axis. Okay. This part is done. Okay, we have this apply force. And the last part is we need to update the world. And we use it with the step that we already specified in the parameters. And we also use the delta. But here we will specify the minimum between the delta and this value. It also comes from the documentation, but this is basically meaning that we will not have less than 60 frames per second. And we have the set position on each frame just to update the position of the car. And don't forget about the rotation as well. It's just the angle. And I think we're done with this basic setup here. So let's check this out. There we go. Nothing yet, but let's zoom out. And as you can see, the car is there. It just has the position of 1000 for both X and Y. And as you can see, the physics engine seems to work. We just move back and forth. Okay. Yeah, it seems to work fine. I would also change the initial position of the car so I don't have to zoom out every time. By the way, this initial position I think is not going to affect anything because the physics engine will take over the car anyways and it will just set the position. So let's put it as 0. Now, to improve our physics, we have to talk about different forces affecting the car. So let's start from the theory. So first thing, we have drag force. Drag is just the wind force, which is affecting our acceleration. It helps to decelerate, but also this force is growing with the speed. So the higher speed, the higher drag. Just like the drag force that grows with speed, we have lateral force. Lateral force is growing with the speed, but only when the car steers with a big angle. It happens because the car, or the object, resists the change in direction due to inertia. We also have lateral friction. For simplicity, is going to look exactly the same, but the friction will affect the opposite direction. And it will be also more persistent. That's why the car will eventually stop. So getting to the code, we first need to specify the new parameters that we're going to have. Let's specify the steer first. And we need to represent it in radians. So we just do math.pi divided by 180. And we just multiply the steer angle. Then we have the wheelbase, which is going to be 100. So now let's try to use those. First, let's just clean up this part. We're not going to use this use effect anymore. And here, to make less code, let's just kind of improve it a bit. Here we have a lot of repetitive stuff. So let's try to refactor first. We will specify the parameters like is up instead of checking every time the arrow button. So here we would have all of those cases. Alright, now let's specify the actual input for each of those. Okay. And now I think it's time to think a bit about refactoring, because here we have the block that is used to push the car forward, which is using the engine to set the vector. But we would actually need this forward vector so that we can use it in our logic. So I think it's good to refactor this a little bit. And we're doing so by using the variable engine. We check the new is up variable and do basically the same. Here, this logic is exactly the same as it was before, just a bit more readable, at least for me. and then we apply force when the engine power is there, and there we specify the vector times engine for each axis. Okay, and now we have to specify the vector, but it should be done outside. And to do this, we're gonna do something like that. We will specify the block vectors. We have forward vector, and it's gonna be exactly the same. We just convert the angle from the car. What we would also need is the velocity, and this velocity can be done like this. We have this car velocity. All right, and now we're going to implement the steering input block, which is crucial for our drifting mechanics. And here we're gonna do some kind of trick. We will represent the steering as 1 and 0 on each side. Okay, and we will also make it like this, so that when two inputs are pressed, we have just 0, and we make it steer input times the angle, which is represented as a steer variable. Okay, let's move it up a bit, or maybe let's give it a name as force. All right, and now it's time to create actual steering logic, because we already have the input. Okay, let's specify this forward speed, which is going to be a dot product of velocity and the forward vector. Here we have some issue just because there is no type, so let's specify the type. Okay, and maybe we should also specify, however, no, I think it's not needed. Let's take a look. No, I think it's not needed because the velocity is already of this type. Okay, never mind. So here we just check if the steer input is there, and also let's check if there is some speed. We just check the absolute value of the forward speed, and let's check for some abstract value. It's done because we need to have some kind of speed in order to be able to steer. We cannot do that in place. And here's the formula of the turn radius I just found online. Not gonna be lying. And here we would also put some small value in order to prevent dividing by 0 if that happens. Here we also have the angular velocity of the car, and we just put those calculations. That should be it. And after this, look, here's the nice trick. If there is no input, we would just constantly reduce the angular velocity. So, all right, I think that block is done. So let's check that. So it kind of works. We have the force generated by the engine and we have steering, but we don't have any friction here. It's good that we have our physics kind of work, but what we need is to add some forces that stop us. The friction, which is caused by the contact of tires and the ground. We would also need the drag force that will prevent infinite acceleration. because here we just accelerate infinitely. And in order to implement this, we would start from new parameters. So let's specify the grip, drag and drift. And starting with the drag, we would have the factor, which kind of means that when the drag force starts, in our case it would be 30% of actual speed. The second parameter, the max, would be just the maximum speed of the car to prevent infinite acceleration. And now it's time to use those parameters. So first let's specify the blocks that are going to be used. Starting from the drift, then we have the lateral forces and we have the drag. And the drag force is the easiest to implement, that's why I start from this. Okay, and we just apply force when there is no engine involved, meaning that we are not accelerating, and we just apply force to the opposite direction of the car's direction. So as you can see, we have this factor of the speed, and we do the same for the y-axis. And this is basically done. And let's just make it more compact. And after this, we will check out what we have. All right. So let's take a look. So as you can see, it stops us when we move forward or backwards. But when we steer, it's actually not. And it should not, to be frank, because in this case, different forces should kick in, and we're gonna implement them as well. So getting back to the code, let's specify the parameters as usual. We will also have some kind of abstract factor, and we would have the minimum speed at which the drift is activated. And here we would specify the drift factor, the normal factor, and the lateral factor. This is only for friction. So at drift we have the friction of 0.3 and so on. So here we would put our drift logic, and first we need to know when there is a drift. But for this we need to know the speed. So here we just get the speed, which is just the length of the vector, and let's introduce the variable is drifting. Is drifting means that we're using our engine, so we're just throttling. We have some kind of steer input, and we also have our speed, which is more than the minimum to activate the drift. And also we need to take into account this drag factor. We check if it's more than the drift factor. Well, it's simply because we don't have to activate the drift at some kind of super high speed. It's just because we do not even drifting at that high speed. It should be within some kind of range. And here we have this final lateral force, which is basically the dot product of the velocity and the vector. Let's call it like a right, because we also have a forward, but it's going to be exactly the same. what we're going to do is just to introduce the new vector, which is called right. And this vector would be derived from the forward vector, but we will just turn it. Like this. Now it's time to use this vector here to get the force, and eventually to use this lateral force to compute the grip. So we have already is drifting, and here we need to specify this formula. We just use the drag force. This is also done in order to make it more realistic, so that the grip actually works better when we have lower speed. And here we just specify the grip mode, let's say, when it's reduced and when it's not. And after all of those calculations, we just apply force to the car, all of those values that we have. And we specify this force to the right direction, to the right vector, actually. Okay. And that's basically it. Not sure if this part is super clear, but you're free to play around with the code, try different settings. And yeah, with this basis, I believe you can start implementing any 2D top-down car games. Hope you enjoyed this video. Please like and subscribe to support my channel, and see ya around.